everyone. Well, let us welcome you. We represent Baobaz. I'm Maciej, this is Kamil. Welcome. And the purpose of our presentation, as mentioned earlier, is referring to the topic of "it works for me." Everyone has encountered this in their work. We would like to give you a presentation on tools which can support us developers, in working on projects and to avoid "it works for me" reappearing. Let me tell us more about us and our company. We work for Baobaz. It is an international company with its main seat in Paris, and we are Gold Magento partner, Gold Solution partner, and we recently become a partner of Czyli Group. Czyli provides generally ERP systems, and we provide plugins and modules that allow for cross-operation between Czyli and Magento. Currently, we can say something about the company here in Poland. We currently have the largest number of certified Magento developers and the largest number of Magento developers per square kilometer, because our office in Sopot is currently 30 strong. We have 30 people employed. That much for an introduction about our company. And in a moment we will tell you about something. Well, we'll show you how we deal with the workflow on projects, working with code in our company, and how the tools mentioned in the title, how these tools help us and how they affect our work. Let's start with Kamil. Magento-based projects are usually large or medium-sized projects which require, for effective implementation, they require teams of people. And when you have a team of people, team of programmers, and when you work on a large project, on an application, you need to have code sharing and exchange. But how to do it? A long time ago we used floppy disks, email, flash USB sticks, but these are failure prone. These are unreliable methods. We don't recommend them. But fortunately we have release control systems, version control systems with a large number of them on the market. You have paid and free versions, centralized and distributed versions. In our company we decided to use a distributed version, a distributed system, which has many advantages. And to be more detailed, to more precise, we have chosen Git, JD. Git has some advantages which we try to use in our everyday work. It has distributed architecture and the ease to create branches and the general speed of the program. Our model of repository and version or release control system is a distributed system. However, it is centralized because we have a central element which is a remote repository. And the largest advantage of this model is that every programmer has his own local repository. It means that apart from the code itself, he has the whole history of all changes, of all modifications, which is very important because in the case of defect or failure, a crash of a remote repository, we can restore the entire code by recovering the most recent, by restoring the most recent local repository. It also means that programmers can work independently because commits are not performed to remote repository, they are done to local repositories. It means that there is no interference between particular programmers, and our commits do not interfere with one another and do not collide. And if you want to share our work, synchronization is needed with the remote repository. And only then can other persons see our changes. In case of a faulty network link in our company, the person working at a certain workstation, they can continue working, which means we have the whole history of modifications. We have more possibilities of our version control system. We can perform commits, and we do not require a network connection for this. It is only required when we want to share our work with other people working on the same project, or just to download certain modifications. If it is restored, if the connection is restored, or when the connection is restored, we can seamlessly continue working. So to sum up this slide, the most important benefits, the most important advantages of this model of repository is that each workstation has the whole history of all modifications, and that there is conflict-free work of many people on different tasks in the project. Now Maciej will tell you about the life cycle of applications that we have chosen in our company. Thank you. I think that to understand the further part of the presentation and why we use particular tools, we have to start with presenting what the life cycle of the code in our company looks like from the technical point of view, whether during the startup of the project or during maintenance, when we deal with new functionalities for the system, for the customer, or when we just fix our bugs. First of all, we have a developer's machine, a single machine for each programmer. As Kamil mentioned earlier, everyone has their own local repository of the code of the project, and they are working on tasks that have been assigned to them, features, bugs, and so on. And it is also where unit tests are carried out. The next step is transforming the changes to the integration server. It is an external web server with a working Magento instance for a specific project. Here we carry out integration tests, as the name would suggest. We check how functionalities developed, how they work with other functionalities that already exist, or functionalities that are being developed by other people. Here we test it ourselves as developers, and the lead developer is also testing it here. The integration server also allows us to see what is the current stage of the project for people in our company who would like to be interested in this, apart from the people from the team working on the project. Once we check our modifications on the integration server, they are sent as a release pack. That's another stage in development of our application. They go to the qualification server. Here the customer gets involved in the tests, because apart from us, we are again testing whether the changes have been sent to the server in the correct manner. It is the customer who's testing, and the manager is testing in terms of compliance, functional compliance of what we have written. They check whether what we have written is actually what the customer has expected, what the customer expected. So once it works, once we succeed, once it's approved, changes are sent to the pre-production server. The pre-production server, contrary to the other two, is, in terms of architecture and configuration, apart from external web services such as payments, it is an identical copy of production. And this is where we are mostly interested in architecture tests, whether our changes do not affect the operation of applications in the environment. For example, problems with multi-fronts, which we do not have at previous stages due to cost reasons. Once the customer carries out validation and everything is okay, our changes go to the production server. This is where we only check if the changes have been transferred properly, if someone is not missing. We do not carry out any tests because we assume that all the previous stages that we have gone through, that they have eliminated the bugs or errors that might have appeared. The pre-production server also allows us to test hotfixes if there are any bugs appearing in production, because the pre-production server and the production server are identical, so we can very easily test our hotfixes, and we can send them to the production server, which makes us more responsive, and it allows us to respond quicker to the bugs reported by the customer. That much for the life cycle of the application code. And now Kamil is going to tell you how the whole system is reflected in our repository that we have chosen, how it's reflected in GIT. In order to implement very simple integration of the lifecycle with the repository, we decided to use a certain model which allows us to easily use the cycle presented here. As mentioned earlier, we operate on Git when, after initiating a repository, we have a master branch. At Baobaz, we have come to a conclusion that it will be a place to store the development code of the application. Git has a tree-like structure where the initiation commit is its root, and all the other commits stem out of this root. So with the history of changes that we want to publish, the code from the master is sent to the integration server at a certain stage, where it is tested by us, just as mentioned by my colleague earlier. After initiation of the repository, we create the vendor branch, which is responsible for storing the code from external libraries. This is where Magento itself is stored. And then the code from the vendor is attached directly to the master, depending on the version that we need in a given moment. This is useful if we create some changes, some interventions in the core. For example, if there is a patch released with a security improvement or improvement of cache operation. So once we have a new version of Magento, this way we can eliminate potential conflicts. If the bug was fixed in the newest, in the more recent release, if this patch is attached to the newest release, we can remove our changes, and if not, we can leave them and they will not be overwritten. In our team, there are many programs working on different functionalities at the same time. So we decided that the best way to use the potential of Git, each functionality is developed on a separate branch. Thanks to this, programmers are separated from one another, not only at the stage of the local repository, but also at the stage of the branch itself. Because performing some changes on particular branches, we are unaware of what is happening on other branches, and the others are unaware of our changes, which doesn't lead to various types of errors, and it allows for more effective work of programmers. Of course, if there is a need to attach some modifications to our local branch, we simply append these changes, because we reached a stage where an external library is required, a library that wasn't there before, and when the whole functionality is developed, and if we are ready for tests, we send them, we connect them to the master. This is where certain conflicts may appear, and it is up to us to solve them in such a way that we do not disturb the process of code development for other people, by other people. And the code from the master is sent to the integration server at that moment, and it is tested. This model requires allows for Scrum methodology to be adopted here, like iterated programming. And if the end of an iteration comes and our customer requires a certain pack to be sent with certain functionalities, we create a release branch which stores only specific functionalities that we agreed to provide to the customer. A release branch is then published on the qualification server. All bug fixes are done on the release branch in such a way that we do not disturb the development process of the application. And once they are implemented and tested, they are sent back to the master to avoid propagation of errors. And here, the biggest advantage of the release branch is that it doesn't block us in any way. Backfix doesn't block the possibilities for development, and our development code doesn't prevent from backfixes being implemented. So we cannot append the code from master to release at any moment because it can contain new functionalities. We freeze the development for the release branch, and we only provide the agreed functionalities to the customer for testing. If everything is ready and we get green light, the given release is attached to the RTM branch, RTM meaning ready to market, and it contains a stable code that is ready to be sent to production. But first it is sent to the pre-production server, where additional tests are carried out. At this stage, some bugs may appear. Then we create another branch directly from RTM, which is called hotfix. A certain hotfix, if you are certain that the code has been fixed, it is then sent to RTM, where it is from where it is sent to the pre-production server, where it is being tested, and then it goes to the production server. Of course, hotfix immediately goes to the master branch to avoid the previously mentioned propagation of bugs. The RTM branch stores subsequent stable versions of the application. It is a mirror of the production code. It means that at any point in time, we can easily roll back if there is a critical bug and the customers are not able to place orders and to fulfill orders, and we have to respond quickly to restore the earlier version of the application. Another release is related to another branch. Just for simplification of this diagram, we have left the same one, and then it goes to RTM. So the code cycle has been mapped to the GIT possibilities, capabilities, and the biggest benefits, the biggest advantages here include a lack of blocking of hotfixes and backfixes during the development of the application, and also independent work of many programmers on different functionalities using branches called features. Branches in GIT are not costly, they are very quick. Therefore, we tried to use their potential in best way possible, but we know that this model can still be improved, and we are trying to look for possibilities for further improvement of its operation, because we know that it can be problematic to work on an application with several websites at once with different functionalities at each of them. But despite obvious advantages of the model, it has some disadvantages, but Maciej is going to tell you about them. Let's come back to the previous slide, where I was showing you the entire life cycle of the application from the technical point of view, with particular stages, servers, stages of testing, and so on. Apart from the obvious advantages that I have mentioned and Kamil has mentioned, it also has certain drawbacks. One of them is the fact that it's costly. For each project, apart from the production server, if the customer decides that we will be hosting the site, apart from the production and pre-production server, we need to have 2 additional servers with copies of our application. So it is costly, not only due to hardware, but also costly due to administration. That is money for people who are dealing with it. Another thing is the issue of time and publication itself. Let's imagine we have those 4 servers. In case of the integration server, these are incremental publications, so we do not have so many problems here. But let's imagine at subsequent stages, let's imagine the nightmare of publication. We know the structure of the file tree in Magento. It is, well, simply put, very complicated. So even if we have a very small release that has to be published on the qualification, pre-production, and then production server, if we are to publish the entire module, then it's okay. If it's a module and changes to particular files, whether in the module or in the templates, it's where problems arise. Because in theory, we have to manually connect with the FTP server and transfer only the files that we are interested in. And we have to be careful not to forget something, simply put, which is difficult in terms of 3 stagings. GIT helps us here. Let's imagine we have a certain branch to be published, a certain branch of the code, whether be it release or some modifications. We need to know when we started our changes. Each commit in GIT has its ID. We need to know when we started the changes, when we finished the changes, and then playing on the console, we can transfer only the files which have been modified. In the first case, we can just list the files that have been created, and based on that, export a pack and send it manually to the server. Or, in the second case, requires our production server to contain a local instance of GIT repository, where we can first export our changes in one file, in a patch, and then manually they can be sent to the server. It is some kind of a solution. It is not a perfect one. The main problem here are rollbacks. But if something went wrong despite our testing and we have to come back, we have to roll back to the previous stable release, then it's becoming problematic. And another element is the need for maintenance mode when we publish. If it's one or two files, it's not a problem. If there's several dozen files, it is better to shut down the page for that moment, especially if we are touching the payment or checkout module. We do not want customers to see some temporary errors due to files being copied at the moment. This is what GIT gives us. We can also have a different approach. That's what we use in our company. We became interested in automated publication, how to automate the transfer of our subsequent releases to the servers. There are several tools supporting so-called automated deployment. We've chosen Capistrano. A few words about Capistrano itself.
Programowanie Ruby?
Ruby is a programming language, initially prepared for projects in some Ruby on Rails, but it has been growing rapidly, so a number of new modules have been created and extensions which help us use Capistrano also in those projects we're not using Ruby on Rails, including PHP projects. Briefly about the use of Capistrano. Capistrano requires certain settings. You see part of the structure of our project. For the developer's working station, in the source catalog we have the entire Magento code, and we have pickup file, main pick. In other catalogs that's loaded by Capistrano when working with it, where we have information about modules which we are using and additional configurations necessary for the project. Configurations as such are held in this the environment folder, and then we have a folder with configuration for various servers, environments where we can have automatic publications, like the server's address, the main route, and some other information required for the Capistrano. And we also have a configuration to adjust Capistrano for Magento, because by default the structure of project in Capistrano is the one like in Ruby on Rails, and we adjust the native tasks of Capistrano so that it can work with Magento, and with the structure we decided to have the use of Capistrano to publish our changes is the cap console and deploy. Cap prod deploy, you have the RTM leg source at the server, development server in config deploy prod Ruby. So you don't have to access the FTP server because Capistrano connects using SH as a protocol and transfers files itself. You don't have to worry about packs with reads. Well, Capistrano handles it, and on the server side, when you start and you make the first publication, you modify the instruction, you do cap prod deploy setup, and as this catalog structure on the server, you have the current catalog which is created. That's which is shown by the root of the server, so automatically you have what is in the catalog is downloaded, and we have other folders, so they're empty. Catalog, the current catalog is a symbolic reference to the actual application code, which is in the releases catalog under the given date. So the current catalog points to the latest release, always. So what does Capistrano do on the server side? First part is reference to cache copy. That's the local GAT repository copy of our project. So Capistrano takes the latest code from the central repository, goes to the code given in the specified in the configuration, and copies the entire Magento code to the releases catalog under the latest date, year, month, day, hours and minutes. After the entire Magento has been copied, local XML file is deleted, as well as media folder VAR and other folders which have dynamic elements from Magento, such as staging or sitemaps. Another stage then is to have symbolic links to shared elements. So with each and every release, you're not copying the media catalog with pictures for customer products, and we're not removing the VAR catalog, you're not using the logs or the cache, which is there. And the last part of our publication is to connect the current catalog from the previously release to the newest ones. And then you have other functions like clear cache, clear cache, or index, and other. So you don't have to put your website maintenance, because the publication takes about 5 minutes, roughly, because it's on the server's side, and switching to the new code version takes only fractions of seconds, which is why hardly any customer will see any negative impact on the operation of the website because of such a short switching time. So a brief summary of Capistrano. So solution advantages include configurability, was created for Ruby on Rails, but it can be made to work with other projects, including Magento projects. The ease of rollbacks. The only thing you should do, if it turns out that the code we developed is not working, is to reconnect or switch to the previous release using the symbolic connection. And if there are any changes in the rollback database, you can't avoid it. So Capistrano saves developers or redevelopers time depending on who publishes. Before we switched to Capistrano, large publications for our larger clients could take from 1 to 3, 4, even 5 hours, sometimes even overnight publications took the whole night. Now the publication process is limited to such 5 minutes, cap, prod, deploy, enter, and that's all. Well, Capistrano as a tool also has disadvantages. So the sad Windows users problem is one of them. Capistrano doesn't work that well with Windows. Why? Because the Capistrano has 2 possibilities for logging in. First, you can log into the server with a username and password, but to have the same username and password for each and every server. And the other option is to use the RSA code or key for user, but the forwarding for this key RSA under Windows doesn't work. The problem is the Ruby language, not Capistrano itself. And then another problem is that with each deploy, it's a copy of the whole Magento code. Obviously, you exclude the VAR, not dynamic catalogs, but it weighs, it's bulky with all new changes. Each new deploy is between 200 or 300 kilobytes, so well, it grows on your hard disk. And last thing, it's a console-based solution, easy to use, but for those users who are not familiar with using consoles, maybe not scare them, but maybe wouldn't be that comfortable. Well, that's all from us. So a brief wrap-up. So we mentioned about code lifecycle, version control model we have at our firm to reflect the cycle and make life easier. And we eliminated the nightmare of publications. We make the process fast and nice for us, pleasant for us, programmers, and the customer who doesn't see any side effects, like switching to maintenance during publication. I don't know if we have questions for Q&A, for time for Q&A. If not, then we'll answer your questions during the break. Thank you.